Okay, perfect. Can everyone let me know if my microphone is okay? Just because my laptop is on its last legs, and when I run even like a code editor at the same time as, you know, like a Jupyter Notebook and a few different things, it often, and I'm recording on Zoom as well. So just let me know if you can't hear me. I might, once I start sharing screen, I guess I might turn off my camera. Here's Prakash as well.
Yeah, sounds okay so far.
Okay, cool. Yeah, I'm trying to, like, we're hoping to raise VC money, and so like I think then maybe we'll be able to buy new laptops, and so I don't want to spend my own money, you see, so I'm just trying to hang on for the last like few months. So maybe I should cut that bit out of the recording, I'm just thinking, but okay, cool. Let me share my screen.
It can take a long time until you get VC money.
Do you think? Yeah.
Yeah, there's a lot of steps to do.
You're still going, right? You've just like, you've been going for a few months.
I'm just paying our lawyer, so I mean it's a long process. And
yeah, okay.
But I can advise you a bit if you guys want.
Okay, that would be great.
How to save time.
We're like, yeah, we've just started talking about it a bit more seriously recently, so yeah, we can definitely catch up on that. Okay, cool. Let me share my screen. Desktop 2. Okay, I'm going to stop my video as well. Okay, can you see my screen? Like a Zoom thing at the moment?
Yep.
Okay, sweet. Okay, so where to start? Maybe we can go to our GitHub repo. So I added this beautiful new picture, as you can see here. So yeah, I guess this is where what we did last time. Last time we trained DCGAN locally, so we just trained it in a notebook. And what you can see here are the results. So basically, we trained on CryptoPunks. This was after like 5 epochs. This was after like 25 epochs. And then this was after like 100 epochs. And you can see, it looks like we might be getting some like new punks and stuff. So I haven't gone through the whole data set obviously to check, but these look pretty good, I think. So yeah, I've just been like hacking on this just today. I've changed a few different things. So I guess what I said last time was, since we ran it locally, so this might be the steps for a data scientist: run locally on the sample data. And then once you know your code runs, you can send it off to compute to data. And so we did the running locally step last week. And then when we're sure the algorithm works, the next step would be to like convert the code. So let me show you what it looks like. Local training. I've actually changed a bit of this as well, by the way. So yeah, so the bit that I changed, previously we like extracted all of the files from the tar file, but now I actually just load them from the tar file directly, because, and maybe Robin, you'll know this, do you have like access to local disk space when you're using compute to data? So could I like run an extract function to extract into like a local directory and then just, you know, use normal image loading, or do I need to load directly from the tar file? I don't know if you know.
Why would you have a tar file?
That's just how I uploaded the punks as a zip file in the, I guess maybe that's.
No, I mean there will be a directory mounted into your Docker container, which is the input. Mm-hmm. So like I would rather have the input, you know, untarred already. So like that the input for the Docker container is already not the tar file itself, you know, but extract the tar file. I would say that this step here of getting the data ready for consumption should probably be handled by the data set, you know, by the server, so that in the input it's already correctly input. So
okay, yeah. And also, like the other question, actually, just while we have you here, I was going to ask was, so let's say I work on a private data set, and I'm a data scientist, and I don't actually have access to the private data set, but I want to add some value by processing the data and then publishing this new processed data token. Like, how would you set it up? Because like where would that data be stored, for example? So could the owner of the private data set make some extra storage space available for other data
So
scientists?
there's another folder, which is the output folder,
Mm-hmm.
mounted into your Docker container. So this is where you then produce the results into that.
Okay, but if it's a private data set and you process the data,
Mm-hmm.
the owner of that data set isn't going to want you to get access to that output folder.
I mean, so like in the end, you have to discuss this with the data provider, you know, because like they have to whitelist your algorithm,
Mm-hmm.
you know, the one that you want to run. So like, let's say now you are training here some, if the output then should be some new images, then of course, I mean, you have to, the data owner has to decide whether they allow such an algorithm to run or not, you know. But if it would be a model, then in the model, it would probably be compressed somehow, right? So like the model would be then a generator, for example. If you train a generator, and then, yeah, if the data owner allows that, so then it would be okay.
Mm-hmm. Okay, and what if the data owner was happy for people to process the data, but they just didn't want?
So for example, for data union, we are planning something like this, that we want to allow people to run algorithms on our data, for example, to annotate it. Let's say there are images and somebody says, hey, I have an algorithm, and I think, for example, for these car images, I could add additional labels, you know, that I can find out on images whether there's a car or not. And we will say, okay, cool, run over all our images. And then here's an API. And in this API, you can then report, you know, like you can suggest from your wallet, you know, you basically sign then this from your wallet. You sign, okay, hey, this is by the way, this is my new annotation for this image, and then you add value to the data set. So we are actively planning to have that as an option, because I mean, this is the same as, it's kind of the same as somebody going to our website and then opening the images and then adding this annotations manually, right? So like we want to have this in an automated way so that people can actively add information that they gather with the algorithm. But I mean, still, the algorithm is then going to run on our data. The data is not getting copied out, but it's basically then computed data on this data. So you basically ask us, can I run this there? You do it. You produce the result for these images. Yes, here's a car. There's no car or something like this, you know. And then you can add this information.
Okay, and what if, like, so that's in the case of like labels. So
yeah,
by knowing the labels, you still can't see the images. So that sort of processing is fine to like put in the output directory, as you said. But what if the processed data set still looks like the images? So let's say something really simple. Let's say you, data union, have saved images as 256 by 256, and then someone wants to add value by, you know, changing, resizing to 128 by 128, and for some reason this works much better. So we also
have an upload API. So then your algorithm could then say, okay, now I upload all of these images, and I say, okay, these are new images. So then our algorithm, which checks like whether an image is new, will check whether this is acceptable. You know, it adds enough new information to our data set. If yes, then you upload a new image. So you basically, if somebody then wants to buy the higher resolution image, you know, then they could do that. But our algorithm that checks for new images takes this resolution into regard. So like, yeah. Okay. I mean, if you just make an image smaller, it's not going to work. Maybe if you make it larger with super resolution. I did not try that actually myself. But yeah, in the end, we have like an upload API, so that then it's okay. You know, like so. But this then will be in your code, right? So like in your code that you execute, I will see, or like probably it would be me in the beginning who's checking like which algorithms are getting whitelisted, and then if this uses our upload API but doesn't copy the images out, it's fine for me. You know, like then you're basically generating something new. But I mean, that's like with our image data set, it's special, right? I mean, other data sets do not behave like this. So we actively want to embrace this. You know, that somebody can use algorithms to generate something new and then add it to the data set. So
yeah. Okay, cool. And like, yeah, so that's exactly what I was asking. Like if someone processes the images, but the processed images are still kind of private, maybe the data scientist wouldn't get access to those and it just stays on the data provider server, but as like a new data set, for example.
I mean, here in the case of data union, it will just be added, like, so that's also the spirit, like if you would have, for example, a sensor data union, and then you have like a long sensor rows, and then you will say, okay, now I add something to that, I make it better, I filter out some noise or something like this, then yeah, you then add this as a new, like a processed version of that. But I mean, in the end, like if you do it like this via compute to data, and you put the results directly back into the data set, then they never leave the server again, right? So I mean, there's no harm for anybody.
And what if it's quite different to the existing data set, but you can still get information?
Well, then it's something that I mean, in the end, like this process happens when we discuss about getting something whitelisted, to the data set.
Yeah, true.
That's the point where, I mean, okay, if you have an idea there, I would rather come and talk about it early, like, so before you start all the work. But yeah, I mean, in the end, why not? I mean, like, if this makes sense, then why not?
I think we were talking about before, like as data gets processed, you could almost have like a data version control. And so like all the way from the raw images to maybe even like saving the feature embeddings or something like that. And so like for feature embeddings, for example, they're quite different to the images, but like maybe it's useful to save them as a data token, for example. And in that case, you probably still don't want the data scientist to see the feature embeddings. And so the data provider would have to provide the storage for those feature embeddings, for example.
So I would then I would call this then an annotation, like something like the feature embedding would be something that is attached to the image, So like if you want to, so that you basically say, okay, I want to use this feature embedding, and that this is something that you can find in the data portal that we're providing, so that you can say, okay, now I want to have not just the original image, but a feature embedding for this and this algorithm, for example. And then you can say, okay, now I will just work with that instead of working with the original image to save myself computation time to calculate this feature embedding. That would be something, I mean, like for us, it would be okay to store this also next to the data set. I mean, in the end, like it's connected to the image, right? So basically the feature embedding should then also be connected to the annotations and everything, like so like in a way, it's just adds more to this specific data point. That's how I would then treat it, also then to keep it there next to the data.
Okay.
But in general, like, yeah, why not? I mean, like we are very open to all experiments in this direction. If you have some ideas, we can try it out. And like we have a lot of storage, so it's not necessarily a problem. I mean, one storage provider told us they add 20 petabytes per month to their storage, and if we can make that full, they would be happy about it. So like, yeah. Lots of space for experimentation.
Okay, cool. Yeah, sounds good. Oh, here's someone else, Dave Potter. I haven't met Dave before. Yeah, cool. Hey, Dave. I'll keep going anyway. Yeah, so this. Oh yeah, hey Dave, how's it going?
Hi guys. Sorry I'm late.
No problem. Have you come here before? Is this your first time?
No, I came a week or so ago.
Oh, okay, great. Okay, cool. You know the drill then.
Yes.
Yeah, we were just kind of covering some of the stuff from last week, and so yeah, this was the notebook we worked through. Basically, just loaded the sample data here, showed us, then defines DCGAN. We'll define our punks dataset in PyTorch. And so this is the bit that I changed. I changed it so that it loads from a compressed file, just because that's how I uploaded it to the data marketplace. Then we have our data loader, define our generative model, and then run training, visualize the results. And so this is what it looks like at the start. And then you can see like after different numbers of epochs, it trains and gets better. And so that was running locally. So the next step is to run compute to data. So I just want to show everyone what the compute to data looks like really quickly. And so if you go to the Ocean Pi library, they actually have a C2D flow. So this is the Ocean Python library, basically, and there's some useful readmes. So this is the compute to data flow. And so this is like, basically what I've done is just copy this to a notebook, but the difference is that this runs on a local version of the blockchain. And so you use a library called, or a repo called Barge. Ocean Barge is the name of it here. And what Barge does is it runs Ganache, which is basically, it just runs the blockchain locally on your computer. And so I just changed this bit out so that we're using the Rinkeby testnet basically. So that's the only difference. And to use the Rinkeby testnet, you basically just need to load the config file that I've put in the repo. And so, yeah, that's basically the only difference, but I think it's useful to just run through it quickly so that everyone knows what running computed data looks like. And so we're not doing this for our generative model, but we'll just do it for a basic example first. And then I've done some work on changing this to work for our generative model, basically.
I've been playing around with this after you pushed this out, and I was just playing around with it today. So one thing I noticed is the blockchain, all the on-chain code doesn't work every time. Have you also noticed the same thing? So sometimes.
Yes, sometimes you need to rerun cells. It's a bit like buggy. I don't know. I thought it might be this transaction timeout. Because I think Rish, you were the one that realized that the new version of the Ocean Python library requires this extra argument. And I think you had this set to like 10 seconds, but it kept timing out for me. And so it took me a while to figure out that you just need to increase this. So I used 20. So maybe it even needs to be more than that. That's one thing it could be. But even now that I fixed this, I do need to rerun things sometimes. It's quite strange.
Exactly. And that threw me a bit, just saying there's some bug somewhere in the code, and then it's not like that. You just rerun it, and sometimes it just works. So it's the on-chain thing, I think.
Yeah, that's what I was actually going to write in the Discord at one stage. I was going to say, like, if someone is stuck with an error, like, just ask straight away, because there's no stupid questions. You might think that you're doing something stupid, but it's probably not stupid. And like, because there's quite a lot of bugs in the Ocean Python library and stuff. And so rather than waste time, if you're getting stuck on something like this transaction timeout, for example, just like, it's probably not a stupid question, I guess is what I'm saying. So if anyone is running this and getting weird errors, like, just go straight to the generative art channel and ask, and maybe someone else has come across the same error. But yeah, it's still buggy, I guess. It's still alpha Ocean. So like, there's still huge changes between different Python, Ocean Python releases and stuff, versions. So yeah, it's just still so early, I suppose.
All right, great. Good to know that.
Yeah. But if in doubt, like, if a cell fails, just run it again. Try it a few times. If it keeps happening, then maybe it is a bug. But if it just happens once, it could just be the case that you need to run it again. Okay. So oh no. Oh yeah, okay. I changed where the config file was. So the config file is no longer in the notebooks directory, it's in the main directory. And I use this import init paths. So this is just a trick for when you're running notebooks. If you want all of your import statements to be the same as they appear in your repo, I just use this init paths function. So where is it? Oh yeah. So this is the init paths Python file. And all it does when you import it, it just changes your directory to the parent directory, basically. And that means that when you have your import statements, the import statements that you have in your Python file are the same as you have in your notebook. So it just means that you don't have to change code between the notebook and the Python file, if that makes sense. Just a little trick, don't worry too much about it. So yeah, this just imports your config. So we're using the Rinkeby testnet. This time we're going to use two different keys. So we're going to have Alice and Bob. And like, Alice is going to publish the data asset, and then Bob is going to purchase. Alice is also going to publish an algorithm, and then Bob is going to like buy the data and the algorithm, and then he's going to start a compute job, basically. So that's why we need these two wallets. And so this step first, this is just setting up Alice's wallet. So we did this like a few weeks back. Make sure that Alice has ETH in the wallet. This is another thing that that might throw people. So because we're using, these are the exact same private keys that are in the Ocean README. And so basically everyone is using these wallets. And so if someone else is running the tutorial, if someone else is running through this Ocean tutorial, there might actually be no ETH left in the wallets because everyone else is using the exact same wallets. And so if there's no ETH, like the first time I did this, I actually had to request ETH for these wallets from the Rinkeby faucet. And so if there's no ETH, yeah, just basically go to the Rinkeby faucet, which I think we discussed before as well. And you need to tweet about it and get some ETH basically. So that's another thing, like that's another thing that you get an error from, and you might think you're doing a stupid mistake, but you're actually not. I guess what we could do is just change these private keys so that it's like only ones used by Algovera. But even in that case, if loads of people are hacking on this, those wallets might run out of ETH. And it's all test ETH, remember, it's not real. So, because we're on the test now. Okay,
so I was thinking whether that assert statement of yours, you know, where it says, you know, if you're shouldn't it be less than 0, or I don't know, but it kind of never.
We want the ETH in the wallet to be more than 0.
Yeah, so it's more than 0, but you assert that you need ETH when you're less than 0 or more than 0. I don't know.
If it's 0.
Yeah. So or less than okay. So I changed it for myself. I went back to the old code where you just kind of, you know, get the ETH value, like how much ETH you have already, cool. as a you know, it prints out there.
I use that a bit too. You can check it that way. So you could just like, rather than asserting that it's greater than 0, you could just print out how much is in your wallet, for example. I think that's what you're talking about, right? Yeah. Cool. So, okay, so now we're going to publish a data asset. So just publish a data token like we've done in our very first hacking session, and also for the CryptoPunks, the way that I did it. And so this is just doing it by using the Ocean Python library. So I think we did it through like the GUI, like the Ocean Marketplace GUI. But you can also publish data assets through the Ocean Python library. And so that's what this is doing here. And the URL in this case is just, I think it's just like numerical data. Yeah. Text data. So yeah, it's not images, it's not like a zip file or anything like that. And so these are just the fields that, you know, like if you went through the Ocean Marketplace, you would have to fill in, you know, who's the author, what's the URL, and different things like this. So it's all the exact same basically. So
okay, I don't want to just, you know, like monopolize this conversation, but I was running through this, so I have some questions if it's okay. I'm going to just ask. So once you publish a set, right? So what we are doing here is we're publishing the data set first, then you're publishing the algorithm, right?
Yeah.
So essentially what was happening, so yes, I mean, it's a little bit later, maybe you go through this and then I'll come. Yeah. Okay.
Yeah. Let me know whenever we get there.
Yeah. Right.
Okay, cool. So yeah, this is just all the metadata for the data set. These are just like JSON values. And then we set up the data service provider. And so this is basically just the Ocean. This is where like the compute comes from. I think it's called, in Ocean, it's literally called provider. And so this is the thing that times out after 1 minute. And we're going to be changing these service providers so that we can use probably data unions, which I'm chatting to Robin about at the moment. But yeah, this is just like basically setting up the data and compute on like Amazon Web Services and things like that. And then finally, we create this asset with the metadata that we already specified. The publisher wallet, Alice is publishing. We're going to use like the out-of-the-box compute service that Ocean provides. And yeah, that should publish it on the marketplace. So we have our identifier for our data set now. Okay, so next step is to publish an algorithm. And so I don't know if we've done this before. I think we did in the very first lesson, but it's very similar to publishing a data set. Just that you need to provide some extra parameters like a Docker image that you're going to use, for example. And so we're just going to use this out of the box Docker image. And so if we go to, these all come from Docker Hub, by the way. So Docker Hub is like GitHub, but for Docker images. And so actually I just set up a Docker Hub account for Algovera today, because we're going to want to use our own custom Docker files. And so once we create a Docker file, I'm going to push it to Algovera, and then other people can pull those Docker files from Algovera and use them to run this compute to data, for example. And so I also forked Ocean's Docker images. And so here they're the Algo Dockers. So this is just forked from the Ocean protocol GitHub. And you can see that they have different Docker files. So this is the one, Brannon is just like the name of this example. And so it's just a very simple Docker file. And so we can add more depending on what we need. Like we're using PyTorch, for example. So we're going to need to create a Docker file with PyTorch. They also give some ones for like Python pandas. Pandas is a popular library. And they also have some for like SQL and stuff. Anyway, we can like keep these here if we want, or remove them, or just like add whichever ones we need basically. And we'll start to build up a collection of Docker files here in the Algovera GitHub. And then also we'll upload them to Docker Hub as well. Okay, so yeah, we're just using like one of the out of the box Ocean protocol Docker files here. And this is the name of the exact Docker file. So Python Brannon. And the other thing that they give is, so you have to give the Docker file, and you also give a URL to where the algorithm is stored. So in this case, it's stored here, and they use this raw format. I don't know if that makes a difference. Okay, and it's gpr.py. So this is basically the file that we're giving us, that we're saying it's the URL. And so we'll come back to this later, but basically,
if you don't use the raw, then you will get the HTML page, right?
Oh, okay, yeah, I guess that makes sense. So you just it needs to be a text file basically. Okay, cool. Okay, great. So this is just the URL to like to the code that we're going to run. And then apart from that, like there's not too much else that's different compared to launching a data token. Again, to find the like compute provider and stuff. And then we publish this algorithm. If I run this now. And yeah, this is going to publish the algorithm basically with the metadata that we gave us from Alice's wallet and with the algorithm service. It's like a compute service and stuff. Okay. So once that runs, the next step is, I think Robin touched on this earlier, but like if you want to run an algorithm on a data set, the data set owner has to approve that algorithm to run on it. And the reason for this is because, you know, whatever we provide in this piece of code that we're going to run, this could just copy the data. And like, if that's a private data set, that's an issue. So like, if we want to keep the data private and someone like runs some code that basically just copies the data set, then we wouldn't want to approve that. And so this is like an extra step. And so it's not ideal, obviously, that the data provider has to go through every single piece of code that wants to run on it. But I think like like people talk about different ways of doing this in future. So maybe you'd have some sort of reputation-based system or something like that. Because it's very manual at the moment, and maybe there's some ways to like improve this better a bit and like automate it. But anyway, for now, like we know what the code is running, so we can improve this algorithm to run on the data set.
So this is where I was having an issue this morning. So it was not going through this part here. I don't know if I can show you my screen. Can I show you my screen where the errors? I mean, you know, if anybody had, these are really sort of really very detailed kind of questions, but I don't know. Like we can always go ahead.
Yeah, go for it.
Okay, here. So let's see. Do I have to do video before I can share my screen?
No, I don't think so.
It still keeps saying host disabled participant screen sharing. Anyway, let me just.
Oh, sorry. I have to give you permission. Okay, go for it.
Okay. So, all right. So I don't know. This is maybe bad contrast. Can you actually see anything?
Yeah, I can see it now.
So that's so the way I'm running it is I'm running it in RStudio because that's the only thing that I really know. So, but then it has a Python. It has a library that runs Python, right? Python code. So, so see, I got the did for the algorithm, right? But now we have to trust this, right? So Alice trusts this, and this is what I was getting. I'm not sure what that means.
Timeout.
The timeout is this is new, like, but before that I was just getting the checksum stuff. Maybe we can do this, you know, later offline or something.
Yeah, I don't know straight away. So yeah, let's just continue offline and
okay. Yeah,
we can try and fix.
right.
But yeah, I mean, in general, I mean, for many algorithms, they will be whitelisted, and then you reuse the ones by somebody else. I mean, in a way, you know, there should be a configuration possible. You know, like what parameters you want to set for an algorithm, and then you can just use the same one again with different settings. I think, from my point of view, you know, like so that it's configurable. But like, you know, in the end, yeah. I don't know, like, are you going to make a lot of algorithms from scratch all the time? Maybe yes, but then maybe there should be some kind of a layer where you say, okay, this part, some part can be changed, you know, and then it's still okay. You know, I don't know.
Yeah. For our use case, like, you know, the healthcare use case, we kind of have to make sure that even the you know, the purchaser who is running the algorithm and the algorithm, both they all have to be sort of trusted.
Yeah, right? That's very important.
Yeah. Okay.
And in the end, like, this can also be a lengthy process, you know, like if you just want to hack on something. So yeah, maybe then synthetic data also becomes interesting, you know, like you have a data set, it's private, but then you somehow at first you create a synthetic derivative of it. And then you say, okay, now this is a public one. Now people can work on that. And then if they can showcase good results on this, then they should come and ask you, you know, if they can whitelist on your real data set or something like this, you know, like, so just to make it easier for in the development cycle, to make it shorter, you know, in a way, because like if for each version you want to then whitelist it on the main data set, it's also going to produce a lot of overhead from my point of view.
Yeah, definitely. And yeah, I saw in the Ocean Core Tech documents, Robin, I think you suggested something about being able to like just change the hyperparameters and stuff like that. Like it doesn't make sense to have to publish a whole new algorithm
Yeah, so we actually find out, yesterday was the Cortec meeting. And then I asked Alex Cosero again about this, that this would be really practical, that we could pass some parameters over. He said, yeah, this is already implemented, but not documented,
Oh, wow. Okay.
So I mean, it's, and now the benefit about all of this is that Akshay, who got the grant for documenting, the code from Ocean. I mean, he's like working for Data Union. So, I mean, he's now, I just funnily, jokingly said he's now getting paid double, like once to document it and on the other side to use it, then also implement it.
Nice.
And then we will include this in the marketplace too. And then, yeah, it should be just, he said maybe 1 week or something, and then we can do it already, sending parameters over. And then that's also very helpful. Yeah.
Okay, that's cool. Yeah. So I was just trying to show you on the marketplace. So after you approve an algorithm for a data set, when you go to the algorithm on the marketplace, the data set will show up here. And so it's like you can just select, after it's approved, you can just select the data set you want it to run on, and then you can press like run from here, and it'll show your compute job and stuff. I couldn't find one that actually has data sets approved, but yeah, this is where it comes up, which is kind of cool.
Is that verification global?
Say again?
Is that verification global? Or is it just specifically limited to your data set?
It depends. Yeah, like there's no common interface for data sets, and so even if you approve the verification algorithm for like 10 data sets, it could just fail when it runs on one if the format isn't the same, for example. And so I guess it depends how generically they wrote the verification algorithm, how well it handles like different file structures and stuff like that. But yeah, does that answer your question?
Yeah, so this algorithm then is verified to run on a single data set or a set of specific data sets, is that right?
I guess so, yeah. It depends, like if they had if statements in it, maybe it would run on more different types. If file structure looks like this, if you see this type of file, if you do this, so I guess you could have lots of different cases. And if it depends how well they've written the algorithm to handle the different cases, I suppose.
I mean, this is a whole new area of tools that can be developed now with computer data, that you are like, basically, okay, there will be a folder mounted into this Docker. It's called input. And then there's going to be some files in that. But okay, what are these files going to be? How are they looking? How they look like? Gathering some statistics about them. There are now this many files. They have this file ending, or this is a distribution of the file endings. Okay, now I'm checking the content of them and stuff like this, or the sizes. This is just like something that like for these private data sets, you don't necessarily have this information from the outside. So yeah. And if you can make something general there, then you can again sell this to somebody, like on the marketplace, so then somebody can say, okay, I whitelist that on my data set, and then somebody else can come and buy that, and then they get information, and then like, okay, now I have this information, what am I going to do next with this private data? So then it's like, it's a lot of detective work that has to go into this, because it's private. That's just different from normally being able to just see the file structure and then go from there.
The more general you write your algorithm, the more money you're going to make, because it can run on more data sets, right? More times you're going to sell it. And so,
yeah, of course. I mean, yeah, basically you need kind of a tool belt, like, okay, is there image data in there? Yeah, okay, now let's look at the image data. How large are the images? What's going on with them and stuff like this, so yeah.
Exactly, yeah.
Or a data provider could also then buy this when they publish the data set first. They buy that, they apply it, and then they just say, okay, I make this public information now, and I attach this here. So like in the metadata, as you can see in the use case, or then a specific part, and then they say, okay, well, I mean, I bought this once, so now you don't have to buy it anymore. Yeah, you can check it out here.
Exactly, yeah. And I kind of I think they're going to put out they're going to have to put out standards for image data sets or something at some stage. I think this isn't something that exists in machine learning at the moment. Like if you go to a few different GitHub repos, they could even work on the same data set, but that same data set would be stored in different formats and stuff. And so there's no common standards for data sets, and even for running models in Web 2 at the moment. And so I think this is once you have a marketplace like this where you can like select an algorithm to run on a data set, I think the interfaces are going to be much better explored, just because people are going to realize it would be really cool if, you know, my algorithm just ran automatically on a load of data sets. And so I think now is the time to like figure out all of this data interface stuff, but it's probably going to take a while. And we need like lots of algorithms first. We basically need to start publishing algorithms, trying to run them on different data sets, and then we'll figure out the problems and like we can solve them, I suppose. And then
I mean,
Yeah, it's really you need an algorithm to publish that it's capable of running over running over data that meets a certain standard. You know, that's the key. It's like having an interface between two bits of software. You know,
exactly.
so
like an API, almost an API for the data, if you like.
So for our image data set, we want to basically, we have our own metadata in our backend for data union, but then we want to have transformers. Like if you say, okay, my algorithm wants to have like Cocoa annotations, you know, like for the images, then you just specify this when you run the job, and then we transform all the annotations into that format and provide it for each image in such a way, you know, or like you say, okay, I want to have like darknet or like here YOLO annotation, then we transform it into that, and then we provide it for an algorithm like this.
Nice.
So then I mean, this is the idea to do it like this, because then, you know, you don't have to necessarily change too much from a lot of the algorithms that are out there, because they also rely on some standard formats. I mean, in the scientific world, at least, they are doing that because these are the ones that are getting are mostly used by the data sets. And then if we can just transform our annotations into the same format, then it becomes easier for the data scientists and for the customers to work with the data.
Exactly. Yeah. And it's like, as it starts to move to no code, that's when the interfaces are going to have to be solved, you know, so.
I mean, you then can basically, that's why we want to then publish algorithms next to the data set, you know, like, so basically saying, okay, these algorithms will work with this data set. So like here you can see an example, you know, and it's a little bit like NVIDIA showcasing that you can, which algorithms you can use with their graphic cards, you know, like they also have extensive examples, but just to be able that developers can start with something, you know, like, and then say, okay, we know that this works because I can replicate it easily, you know.
Exactly, yeah. And like, that's just the data set formats as well, like having common ways to call algorithms. So like APIs for algorithms, that's really important as well, because like maybe you can chain different algorithms together, you know, to create something even better than the individual algorithms. And so, yeah, I think all of this stuff is going to be much improved in the coming years, I suppose. Okay, cool. So where do we get to? Alice has published a data set, published an algorithm, and now this next step is basically, we ran this one, allowing Alice allowing the algorithm to run on the data set. And now we want Bob to basically buy the data and the algorithm. And so they just like transfer. So we're just transferring tokens from Alice to Bob. Actually, Bob would like have to buy tokens and use them. But in this case, we just give him tokens. And then the next step is starting a compute job. And so, okay. Not available. Let's try again. Yeah, so this happens sometimes. Yeah, you see, it's a bit buggy, but yeah, so I'm not 100% sure what all of the different steps are here. So we're saving the data identifier, the algorithm identifier, we're getting the compute service, the algorithm access service, I guess that's another type of service. And then we're going to order and pay for the data set. And so here we just transferred Bob the tokens. Now we're actually going to order and pay for the data set. Then order and pay for the algorithm as well. It's all a bit slow. Takes a few. So buy the data set, buy the algorithm. And then the next step is set up the compute inputs. So basically say, we want this algorithm to run on this data set. Bob is the one, it's Bob's wallet. And it should give you, this is just, yeah, so the compute job is started. And then you can check the status. Okay, so it's like configuring volume. So that's related to the Docker image. You can keep checking this. It might take a while. This happens sometimes too. Don't worry about it. So now it's running the algorithm. And then at some point, it's basically going to say job finished. And actually, that's as far as I got. I couldn't get the result to work. I'll show you what happens in a second. I actually contacted the dev team about this. Publishing results. Oh, wow, it actually worked this time. Strange. Let's see what this gives us. Yeah, this is what I was getting before. Oh no, it's different. I was getting a 404, not found before. It's strange. So anyway, like, yeah, I guess just to sum that up. Let me see. See if we can hack this. Yeah, 404. So this is what I was getting before. So requested URL was not found. I don't know, Robin, do you know what the issue is here?
No, I'm also not sure.
Yeah,
I did not play around with this too much actually. So
I think could be like just a bug in the code or something, but what the last bit is supposed to do, basically just get the results. And so when we run that, it's like a pickle file, and then you just load the pickle file, and then you can just plot what it looks like. And these are the results. And so, yeah, basically I'm going to try and fix this. Like I said, I contacted the dev team, but you saw the compute running. We just haven't managed to get the results back, basically. So yeah, like that's basically this really simple example. And I guess it's just Brannon is like some type of like electronic function or something like that. Because Trent has a background in electronic engineering. So this is the Brannon function. And all this piece of code is doing is just basically plotting the Brannon function and returning the results. And so this is the piece of code that it's running. And so, like I said, it's like a pretty simple Docker file. And then when we run this, this local argument is basically saying, if local equals true, it just runs without computed data. If local is false, it runs with computed data. And so when we run this, it goes to run GPR. So it comes up here. It gets the input data. So this is a function up here. Again, it checks if it's local. So if it is local, just take the file locally. If it's not local, you need to do this thing where, so the data, I guess, is saved in a certain place. So the data itself is, when you get a data set with computed data, it's saved using this format. And so you're just loading the data either locally or using some pre-specified format. Open the file and basically just plot the results, I think, and then save them as a pickle file. So very, very simple piece of code, basically. And so does anyone have a question there? Cool. And so basically the next step for us is we need to figure out, so we already ran this locally in the notebook. So now what we can do is like convert this from a notebook into just a plain Python file. So that's the first step that I did, which I'll put up later at some point. And so I basically just copied and pasted the different cells into the Python file. So this is just a notebook basically. Okay, and what I can actually do, so I took out all of the plotting. So let me see a sec. I just want to show you like how to run it in the Docker file. So let me just change this. Okay. So yeah, you can basically just run it as a Python file. So this is just the exact same thing as us running in the notebook. I just basically copied and pasted. It doesn't output the results. Maybe I'll show you. So the reason I commented them out is because the PyTorch Docker image doesn't have matplotlib installed. Okay, don't know why that didn't save. Weird. I'll fix that. But yeah, so you can kind of, once you're like happy with the notebook, you can just run it normally as a Python file. The other thing you can do is I set up a script to just run Docker. So this is the command you need to call to run the Docker file. And so what I needed to do, I needed to like, you need to install Docker first. And then I was like, you can pull Docker images from Docker Hub. So I just pulled the PyTorch Docker image like this, and then it downloads it. And then like I can just run this Docker image basically, okay? And so you want to use these commands here. I think I'm actually missing some commands at the start. And then you need to mount the different directories, okay? And so it's not going to load in data if I don't mount it. And so you basically need to mount data sets or like certain directories to your Docker file so that it has access to it. So the first thing I did was I mounted the punks dataset, and I also mounted the results directory. So that means that when I output results, it's going to be saved locally outside of the Docker file. The last thing I actually did was just mount this directory itself. So like first, that's what I did first, but then I don't have access to any of this code. So I actually needed to mount this directory to give me access to all of these files. This is likely to change because what you can actually do in a Docker file, so we can start from the PyTorch image, and then we can like run, I can't remember what the exact thing is, but like run git clone, like Algovera generative art. So we could run, you can like clone repos and stuff like that. So this is probably what we'll do when we do a custom Docker file. And then that means that I won't need to like mount the current directory into my Docker file. But for now, I needed to do that, so I can show you this. So we can just run. And now we're in the Docker file. You can see like the main directory is called workspace. So actually, I think I need to change this to workspace. Again, we can change this when we write our own Docker file. And then I can run the Python script. So if anyone's new to Docker files, like just reach out to me if you're having trouble with them, setting them up. I can like put up a good installation directory and stuff like that. But the idea with Docker files is that it just manages your dependencies. And so in your Docker file, like we're just going to like basically say, this isn't going to be exactly what it is, but we're going to like pip install all the packages we want. We can clone certain repos. You can even install, so pip is for installing Python packages. You can install you can install like bash packages and stuff like that. And so in our Docker file, it's basically just going to install all of the different dependencies that we need. And that just means we don't need to play around with like Conda or virtual environments and all that sort of stuff. And so, yeah, basically what I just showed you there was like running the Jupyter Notebook as a Python script. And then I also showed you running it through a Docker file. And so this is all running in our code editor. The next thing is that we need to like set it up so that it's in the format that compute to data needs. And so I basically copied the format of the Brannon example. And so you can see at the bottom, if name equals main. So we're going to set up a script basically where if we, exit this, we can run like Python that. And if we pass an argument local, it means that it's going to run locally. And if we don't pass that, it means that it's going to run using compute to data. Okay. And so when we run this, when we run the Python script, it comes here and then it uses the run DCGAN function, which is here. And again, I just copied and pasted basically what we have from our notebook here. And the only difference is that I use this get input function. So this is to get the data input. And so if it's local, it's just going to load it as before. If we don't have the local arguments, it's going to set it up in this format that compute to data needs, basically. And so that's about as far as I got. But like this is like pretty much almost there. And like I think if I just ran out of time, but if I had a couple more hours, I actually could have run this on compute to data. I just need to figure out, what's the exact way that the marketplace gives you the data and stuff like that. So it's just kind of just figuring that last bit out, and then also getting the results back. But yeah, very soon, like what we're basically going to do is we're going to publish an algorithm on the dataset. The URL is basically going to be this Python script using the raw GitHub, and then we'll be able to run compute to data on DCGAN using the Ocean compute provider. So like I said before, it times out after 60 seconds. And I timed this as well. So if we do 5 epochs, it takes about 45 seconds. So actually we should be able to run this on the Ocean compute provider. So we're just going to get like the most basic results. And then the next step after that is to see if Robin will be so kind as to give us access to some of his AWS credits, and then maybe we can train for like 100 epochs or something like that and get some good results using compute to data.
I mean, the idea would be to give you access to our Ocean provider instead, like then. Oh yeah. You publish it on our marketplace instead, which has nice. A GPU. Yeah, sure. This would be my idea, like that. Then we set this up, and then there it can run then for a longer time,
Absolutely, yeah, we can do that for sure. That sounds good.
And I mean, yesterday in the Ocean Core Tech team working group, they also discussed now that they want to basically enable Ocean provider to be like another source of revenue, that you can be an Ocean provider, and this can then somehow, like the data sets that run, they somehow pay then to the Ocean provider, because the Ocean provider is actually providing the compute, right? So but I mean, it's not going to be in V4 or something, but it's ongoing, forward looking. Then basically this will be another layer, the computation layer. So, because, like, otherwise everybody who wants to run an algorithm on a marketplace either has to have their own marketplace or they have to have their own Ocean provider. And somehow this doesn't make too much sense, like, then you have to specify basically in your data set, what's the requirement for my algorithm to run? Like, how do I need a GPU? Or what GPU do I need? How much memory? How much hard drive space? Yeah. And then the Ocean provider can say, okay, I will fulfill all of this requirement. I would be able to run your job. It would cost this and this much, and then you can calculate this also into the price for running the algorithm. But I mean, that's like future music. So like, yeah, it's not something that's happening right now. But I would be, of course, happy to provide some kind of an environment here to try things out. Of course, we have to then see at some point if somebody's then training something for 2-3 weeks.
Yeah, of course.
You know,
Put us off.
it's always a trade-off, you know. Like,
Yeah.
but yeah, let's see about that. Let's just try, and then we will find out. I mean, that's exactly why we're setting this up right now. I mean, Akshay is now finishing this up, so like, yeah, we have to just connect and bring our marketplace online, and then things can also be published there. The only disadvantage what we're doing right now is that we have our own Aquarius. So then if things are listed on our marketplace, they're not necessarily listed then on the Ocean marketplace, you know, they're not visible there. And that's still something where I'm thinking whether we really should do it already right now, or whether we should use their Aquarius for now.
Okay.
But yeah, because I mean, it's not too bad, you know, if it shows up on Ocean marketplace, because that's also some kind of a little bit of an advertisement platform, you know. Many people know that one. Our URL is dataunion.market, so I mean, it's not too bad, but still it would have to then establish itself, you know.
Yeah, I'm open to whatever on that. Like, we can just see what makes the most sense, I suppose.
Yeah, I mean, as soon as we have something online there, I will post it and we can just immediately try it out.
Cool. Yeah. But yeah, like, the long story is that, like, hopefully by next week we'll have done everything. We'll have gone through the whole process of like choosing a data set, you know, training locally, then training on computer data, and then like we can publish the end result on the Ocean marketplace. And so this will basically be like a DCGAN algorithm that, I guess the next step after that, if we were going to do one, is like how to explore the GAN space. You know, like if people want to buy these different variations of the punks, how can we let them explore and mint one, for example? So that's another thing we could do. Or like, what we want is for after this training course, like, I guess we'd love people to start like hacking on their own problems that they're interested in. And so we've started talking about what the next steps are going to be after we like finish this round of hacking sessions, for example. And we want to give you like multiple options. And one of those options we're hoping is that we can provide grants, for example. And so if someone has an idea of their own that they want to work on, they can basically write like a 1-page proposal, and then like we can review that proposal or review it as a community or something like that, and we can like provide the grant, which could be like, you know, I don't know, $1,000 per grant or something like that. So maybe enough for part-time for 1 month or something like that. And so that's one of the options.
Why not directly take the grants into the Ocean DAO?
Yeah, we could do that. If people want bigger grants, we can like help you to apply for a bigger grant from the Ocean DAO. Or like if we're definitely planning on like using, say, 25% of the funding. If we get the next round of funding, we're going to use 25% of that to fund data scientists in our community. So that could be like $5,000 or something for 1 month. And so we could like, you know, fund 5 projects part-time for 1 month or something like that, or maybe like less for 2 months or something like that. Or yeah, like Robin said, we can help you to apply for grants from the Ocean DAO, which can be, I guess, for your first one, if it's your first proposal, $3,000, yeah. But then that increases to like $10,000 in the second month. You can apply every month. And so this is one direction that we want to help people out to like build their own projects bottom up. But another option is we have these partners like Robin and Data Union, who also like have some data science work that they like to get done. And so Robin's project, for example, is a face anonymization algorithm. And so the idea is we would train an algorithm to anonymize people's faces. And so that's one use case that he's really interested in. And so yeah, we're still discussing what that would look like, but I guess it would be something like bounties or like, you know, paid like retroactively upon like completion or something like that. So that's Robin's project. And then another one, we have the medical images dataset, which is also like Robin is working with them as well. Alonso and Ensight is their name. And so I think Alonso is going to apply for a grant from Ocean, and we're hoping that we can use some of that to fund data scientists to build a medical classification algorithm, for example. And so what we're hoping is once we finish these, you'll have the option of your own project, or like maybe some of our partners, like consulting type projects. And then like everyone will be able to start getting paid to like work on this stuff, I guess. So that's our plan. I don't know if did you want to add anything, Robin, about the data union project, or?
Yeah, I mean, for the anonymization algorithm, I would also offer then co-ownership, of course. Like, I mean,
Oh yeah,
that's like for me, this would be something interesting. I mean, if somebody like, it can also be a group, you know, like that wants to work on that. So we can also, there can be, yeah, we can just start. I will make a document. I will work on that to outline a bit where this should go. But in the end, it's about detecting faces. But then the big, it's not just, you know, like we don't want to become like I don't know, like such a clear view or something like this to detect faces all over the network, internet, and collect it. But in the end, like it's about showing then previews of the data to people, and in this preview to not have the faces anymore, just to make it safer that personal space of users is not violated. You know, but there we can also make an initial bounty. But I think for all of these tasks, it should be a little bit like a explorative, right? So you set some kind of a milestones, and then when you get there, you get a reward, and then you know, like step by step. That's what would be my point of view. And of course, this can then also could be open source in a way, but at the end, we are going to want to publish this face detection algorithm on the marketplace and have it then as one algorithm there. And then when somebody uploads data to Data Union, you know, like new images, they will then also be going through this algorithm. So like, I mean, every new image is one call to this algorithm. So it's going to be used frequently, and then we will also want to see about how we can improve it continuously. So like we want to challenge the algorithm, and if then there's errors and mistakes, then they should also be corrected over time, and the algorithm should get better and better. And the goal is to have, like, at some point, you know, a very, very good one. So, and then, yeah, offering, of course, this also as a service to the whole world, anonymizing data.
Exactly. Yeah. And like, yes, so what we're hoping is that people start to dip their toes in part-time. And then, you know, once we have enough like bounties and, you know, partner projects and funding for MotionDAO and all that sort of stuff, we're hoping that all the data scientists are confident enough to quit their jobs and like just work for themselves. And as Robin said as well, we're hoping to like give bounties for like different milestones, but then also at the very end of it, you get some ownership of the algorithm yourself. And so say for the generative art algorithm, you know, we're going to start like trying to actually sell this algorithm to different people. And so like there was an art DAO like that I learned about through someone I know, and they were basically saying they want to create like 10,000 profile pictures for all of their members. And so like, yeah, we're hoping to like basically commercialize a lot of these algorithms and start bringing money into the Algovera ecosystem. And then when that money comes in, that gives us even more grants to hand out and stuff. And so, yeah, and then on the medical image side, you know, like once that algorithm gets good enough, then maybe we start selling that to like medical companies, you know. So like, yeah, basically we want to start funding data scientists to work on this. And we're hoping that like we can support them enough that, you know, maybe they go half-time in their real jobs and just like work for their own, work for themselves and for their own ownership, basically. And so, yeah, and like, of course, we're going to like provide support along the way as well. And so if you choose a project that you want to work on and like you're having issues, like just reach out to me on Discord. And so we started the medical images channel on our Discord because there was a few people interested in that. And so what I suggest to you guys is, even before we finish the hacking sessions, if that's what you want to work on, like just, you know, start training algorithms. And so don't wait for Alonso's data set, like download some medical data set and create a classification algorithm, and then publish that algorithm on the Ocean Marketplace, and maybe even like train using computed data and go through the whole process yourself on the use case that you're interested in. And if you get stuck at all, like, of course, like just come to me basically, or someone else in the team, and we'll try and figure out the problem. So we want to provide that sort of support, so you're not just figuring out all of these bugs on your own and stuff. Okay, cool. Does anyone have any questions before we finish up? hungry for Thanksgiving dinner, I guess.
Oh, yeah. The various ways of helping people make money on their own is great. I really like that. For just coming, I wanted to ask you a little bit. Yeah, one of the other things is that every on-chain transaction, if it were on the mainnet, sometimes can be it might turn out to be expensive, right? And we have to figure out that part. Like if you have to keep running it like a few times to get
We're
it to work.
we're going to do this on Polygon. There is very cheap, So
Yeah, it's
that's
a
the
layer.
idea of. Our data union. We are going to move our stuff to Polygon. It's just not feasible. Yeah, potentially also shallow, but let's see about this. At first, Polygon, because that's really an established network, and like one transaction is a thousandth of a cent or something. So like you can do a lot of them without really actively going and having a pain through that. And yeah.
Okay, yeah. And just a question for you, Richard, with the DCGAN. You did 100 epochs, and how long did that take you, and what kind of a laptop are you using? So we could run it locally, right? I could run it locally on my machine.
Yeah, it's actually, I don't like, my laptop is just a Mac without a GPU. So I have access to resources in the university that I'm working part-time in. So that's where I trained.
Okay.
I can't remember what GPU it is. It's like a Titan or something like that. Titan XP or something. I can't remember.
Okay. But I just have just a MacBook, and yeah, we'll discover if I can. But it's yeah.
You can use like a Colab notebook. So I tend to work in Jupyter because I've always had access to GPUs, but you should be able to open the notebooks in Colab, and that should give you access to a GPU.
Got you. Okay.
And like, let me know how you get on with that as well. Like, because yeah, just to make sure it works on Colab, that'd be really cool if you could confirm that to me.
Yeah. I'm going to run through the whole thing. First get to compute the data and then to running the DCGAN. So yeah, I'll definitely reach out to you. Yeah. Thanks. Thank you.
That's what I'd recommend to people. If you haven't dived into the notebooks already, just like start working your way through and make sure all of them run first of all, because like, yeah, there's like bugs in Ocean and stuff. And so just go through all the notebooks yourself and just like make sure you understand the different steps and all that sort of thing. I'd say like that's a good first step before you start on your own project, for example. And yeah, just reach out to me if you have any like issues, and we'll help you work through them. Cool. All right, guys. Yeah, just like, yeah, let's keep the communication going in the generative art channel, I suppose, or like, or in the medical channel, or wherever you're working. And yeah, like don't wait. Like if you get a bug and you can't fix it, just like reach out. There's no point, like that's what we're all here. Like other people might have had the same issue before, and then we can solve it as quickly as possible. And that means you can like progress quicker and stuff. So yeah, just feel free to ask. And if you think you're being stupid, like you're probably not being. It's probably like an actual issue or a bug or something like that. Okay, cool. All right. Thanks, guys.
Thanks a lot.
Thanks,
See you
Richard.
next week.
Thank you, Richard.
Thank you. Have a great evening. Bye-bye.
Thanks, everyone.
Bye.
Bye-bye.